Okay, so this is the worked example portion of the video presentation for partial residual plots, right? So the main thing we talked about in the first part is that a partial residual plot helps us decide um, or help us visually see the impact of a predictor on the response, right, in the presence of the other predictors. And so one of the things we mentioned was that, well, looking at the pattern that we see in the partial regression plot, right, we can tell whether a linear term is appropriate for that predictor, whether that term can be dropped, or whether we should consider a non-linear term or a quadratic term for that predictor. So we'll kind of go over an example. So this is data from Zagat in a number of years ago on a number of Italian restaurants in New York. Um, so some information that we collected: price, food rating, decor rating, service rating, and there was kind of this interesting variable whether the restaurant's east of Fifth Avenue or not. So this one is categorical. So a few things we can do, right? So some exploratory data analysis, right? So these are the scatter plots. So they tell us the relationship between just two of these variables, right? So if you look at this plot, it's the plot for price and food. It looks like a positive linear relationship, but this doesn't take into account, right, decor and service. And likewise, right, price and decor looks to be a strong positive linear relationship, and price and service seems to be a strong linear relationship as well. And now between some of the predictors like food and service, right, seems to be pretty decent correlation over here. Um, Food and decor maybe a little bit less, right? And decor and service fairly strong as well relationship. And if you want to take a look at the correlation matrix, we kind of just mentioned all of these. So price is correlated with all the quantitative predictors. Food looks to be more highly correlated with service. Um, right, food and decor a little bit less. And if we fit a linear regression, right, with the three quantitative predictors plus the categorical predictor, this is what we see. And so what we see is an insignificant term for service, right? So this tells us that, right, we could drop service from the model, right, and leave food, decor, and ease, right? Now, on its own, service is related to price, we can kind of see, but because service seems to be fairly highly correlated with the other predictors, so in the presence of food and decor, right, we don't need service. Now, the predictor service, as I say, is insignificant, so we can drop it from the model. But another thing that we could explore is maybe, right, there should be a nonlinear term for service. Now, based on all the plots that we've seen, right, it's unlikely to be the case, right, that service should be a quadratic term. And if you think about um, realistically speaking, right, should the relationship between service and price, right, while holding the other two predictors, was it food and decor constant, is it quadratic? It's probably not the case, but we can still, right, explore that question if you really want to do so. So what I did was to produce this partial regression plot. So the steps on how to produce a partial regression plot. So this is our code that I used. So basically, right, to produce the partial regression plot for service, I regress y on all predictors but service, and then I regress service on all the other predictors, and then I plot. I after fitting these two regressions, I obtain the corresponding residuals, and then I plot these two residuals. So that the residuals from the first model on the y-axis and the residuals on the second model on the x-axis, and that's how I produce that plot that I showed over there. Right, so we notice that this, right, so we want to ask ourselves, what kind of pattern does this follow? Let's scroll back a little bit. Right, it's not really a linear pattern, it's not a quadratic pattern, right? The most obvious one is, it looks like a horizontal band, right, which means that we do not need service in this model, right? So we can remove service and leave food and decor, and whether it's on the east side or not, right? Because this is pretty much a horizontal band, right? So there's no linear pattern, there's no curvature to suggest that we should be considering a quadratic term for service instead. Right, so from the plot, we see plots are in the horizontal band around 0. There's no curvature to indicate a nonlinear term for service should be considered, so what we should do is remove service. from the model and no need to consider a nonlinear term for service. Now on the flip side, let's take a look at the partial regression plot for decor, right? And if you take a look at the plot, right, it does look like a increasing linear trend, and I overlay the regression. So basically, this is the partial regression plot, and I say overlay the regression line of, right, the y on x over here. So this does look like a positive linear trend. I don't see any curvature, right? I don't see a situation where it looks like a curve pattern or not. So from this, I can see the following. Plots are increasing linearly, so a linear term for decor should be used. Absence of curvature means no need to consider a quadratic term for decor. The slope for this partial regression plot will be equal to the coefficient for decor in multiple linear regressions. So if you look at this slope in this partial regression plot, it will be equal to the coefficient for decor in the multiple linear regression, right? So it's about 1.9. And theoretically speaking, the intercept for any partial residual plot should be 0, right? So if you look at, right, the intercept, so when x equals 0, the y is also 0. So that's what we notice, right? So this is telling me linear term for decor is fine. You don't need to consider a quadratic or cubic term for decor.